The digital universe has exploded. It is estimated that the data universe consists of more than 40 zettabytes, equal to 40 trillion gigabytes of data. In 2010, the estimate of existing data universe was less than 3 zettabytes. While this suggests incredible growth over the past decade, IBM notes that 90% of the current data universe was created in just the last 2 years. Yet this exponential growth is as slow now as it ever will be as we move into the future. Data creation and collection is a byproduct of the ever-evolving technologies changing how we live and how we work. Let's spend a few minutes improving our knowledge of big data. Hello, I'm Mark Hamilton, and today I'm excited to introduce you to the CyberCPE Preparing for the Data-Driven Age Nano-Learning Program. This program consists of 5 nano-learning segments. Each qualifies for a 1/5 hour CPE credit. In this CyberCPE nano-learning segment, we're going to answer the question, what is big data and why does it matter? Think about the many ways that evolving technology has changed and continues to change society. Changing the way we communicate and interact with one another, how we learn, how we do business, and how we do our jobs. In recent years, we have come to increasingly rely on connectivity. There seems to be an app for most anything. We have smart TVs, wearable devices, and cars loaded with sensors and cameras. We also have become comfortable talking to devices for assistance. Without thinking, we expect to be able to connect and access any of our data regardless of where we are, and we expect to be able to use it on a multitude of devices. Because of the explosion of the data universe, companies face new technological challenges and opportunities unlike any previously experienced. Currently, we're seeing scalable technological developments and tools emerging that allow us to unlock insight from data in ways that have not previously been possible. Applications like Hadoop, Apache Spark, Tableau, and Power BI are a few of these critically important data analytics tools. We clearly recognize that harnessing the ability to manage big data provides improved insight leading to clearer knowledge. This allows for informed decision making and establishment of competitive strategic actions. So what is big data? While the term big data is relatively new, the act of gathering and storing large amounts of information for eventual analysis is ages old. The concept of big data gained momentum in the early 2000s when Doug Laney defined big data with 3 attributes referred to as the 3 V's. The first V is for volume. The main attribute that makes big data big is the sheer size of the data universe, which we noted exceeds 40 zettabytes. Companies typically manage in excess of 100 terabytes of data from an array of sources. This includes data not only from business transactions and client and vendor interactions, but also data from sources as diverse as social media applications to machine-to-machine sensors. The second V is for velocity. Consider that data now streams at unprecedented speeds, and there is an expectation that processing occurs timely. Application usage and technologies such as card swipes, RFID tags, sensors, and smart metering necessitate dealing with torrents of data in near real time. The third V is for variety. This is an important attribute to grasp. Data comes in all types of formats, from structured, typically alphanumeric data in traditional databases, to the extensive types of unstructured data. When you think of unstructured data, think of text messages, email, photos, PDFs, video, audio, web traffic, GPS mapping, sensors, smart device API traffic, and the list goes on. Since Laney's definition, there have been several additional attributes added to his original V's. One that is recognized as the fourth V is particularly important to accountants. That attribute is veracity. If there is so much volume at such velocity in so many varieties, how do we control the accuracy or correctness and establish reliability? Veracity is about the trustworthiness of the data. So big data is about understanding the volume, velocity, variety, and veracity of the data and determining how it can create value. With the concept of big data framed by these 4 V's, let's look at what's causing the exponential growth. On this infographic, we see perspective of the varieties of data contributing to the growth of the data universe over the technology's eras. It shows the structured transactional data layer, and then beginning with the PC era, we begin to create unstructured human data as we adopt digital tools and create data from them. Next, we see the introduction of the internet and the emergence of social interaction data. With Facebook, Google, and Twitter comes ever-increasing unstructured data collection. The last section, the virtual era, introduces us to machine-generated unstructured data from devices and sensors. The 2 primary contributors to the growth of big data are the rate of internet traffic growth and the multitude of connected devices in our day-to-day lives and in our work environment. Over the past 30 years, the internet has transformed the way we do many aspects of everyday life. Consider that there are 7.77 billion people in the world. 4.54 billion of them are active internet users. This means that almost 60% of all people in the world are active on the internet. The internet offers so much information at our fingertips, and we continuously add to the data universe each time we use our search engine, ask "Hey Google," or interact with our favorite social media platform. I would like to share some big data stats compiled by Domo in their most recent Data Never Sleeps infographic. According to Domo, for every minute of every day, there are 18.1 million text messages sent and over 188 million email messages sent. We routinely use the internet for sharing. Facebook has in excess of 2.6 billion active monthly users, 1.7 of those being active daily users. On Facebook, we share our thoughts, photos, videos, and dispersed content to our friends. We have also seen disruption of business models as we have begun sharing our homes through platforms like Airbnb and our vehicles through Uber. Every minute Airbnb books 1,400 reservations and Uber users take almost 10,000 rides. Additionally, we have gained a passion for streaming. Domo reports that as of today, Netflix users stream almost 700,000 hours of video each minute, while YouTube users watch 4.5 million videos each minute. Streaming is transforming our ways of working too. As we learned during the recent coronavirus quarantine, collaboration platforms such as Zoom, Teams, and Skype allowed us to remain productive in a non-traditional work-from-home environment. I hope this helps conceptualize the enormous data trail that we leave when we use the internet and websites. Let's now discuss connectivity. The constantly improving connectivity infrastructure, expansion of fiber optic services, and the evolution of mobility have provided an ever-expanding foundation for internet usage growth. This evolution has now influenced us in new ways as the expansion of Wi-Fi and mobile bandwidth has dramatically improved the connectivity of sensors and devices. We call this connectivity of devices the Internet of Things. The Internet of Things simply refers to the network of devices that are connected on the Internet. These devices are capable of capturing and sharing data across systems and amongst each other. And the limitations of their functionality is largely a limitation of our existing infrastructure. The next generation mobile connection technology is referred to as 5G. It will bring major changes for Internet of Things application usage in everyday life. Many believe this next level of connectivity opens the reality of managing the data created by autonomous vehicles and the magnitude of sensor connectivity that this would require. Now let's think about where is the value in big data. The value of big data isn't necessarily derived from how much data you have, but from what you're able to do with it. Deriving intelligence and automation from big data is where the value creation occurs. Designing and implementing business systems to gather, organize, and perform analytical computations for all types of data from any source is the key to gaining business intelligence. Big data within a company is diverse. is created by traditional business transactions and by a multitude of data from internet connectivity in operational and production systems. In business environments, timely management of massive amounts of data from multiple sources is difficult. There are difficulties linking, matching, validating, purging, and transforming the data across systems. Artificial intelligence analytics requires focus on connecting and correlating data relationships, developing hierarchies, and establishing data linkages to allow us to convert data to knowledge. There is a growing divide between companies that can manage big data and those that can't. To summarize what we have learned, we now recognize the magnitude of big data and understand that the big data universe will continue to expand rapidly. We also have connected big data as a foundation for empowering artificial intelligence. Investment in big data and artificial intelligence initiatives are strategically necessary. In our next segment, we will dig into artificial intelligence and how it is changing not only decision making, but how we work. I want to thank you for your interest and your attention, and I look forward to our next discussion.